Hi, this is Richard Gain, and I'm going to make a video to show you a 3D print that I've done for a customer on Make XYZ, which is a website where I advertise my 3D printers and allow people to send models to have them printed. And the reason I'm making this video is because these parts, these ones here don't require support material, this one here does, and you can see that from the bottom upwards there's no overhanging parts on these wheels. They've printed nice and smoothly. Very pleased with those. And this part here does have lots of overhangs, so it needed support material in several places, and that support material needs now to be removed. This part was sliced using the latest version of Slicer. It's the 1.0 release candidate version, and the support material algorithm has apparently been improved, so I wanted to try it out and see how it works. So all of these zigzag parts here are the support material. This part here is the bar that is being supported, and all of this stuff needs to go, but without damaging the main structure. So the first thing I've noticed is that it's quite difficult to see which bits are support structure and which bits are part of the object itself. And what you don't want to do, obviously, is damage it. So I like to use a blunt screwdriver, try and squeeze it into the gap and force it apart, rather than using a sharp instrument like the knife to cut it. I'll use the knife later on to clean off any areas that obviously need little parts removing, but breaking away the support material I think is best done using a blunt tool. So I'm looking for the plane between the object and the support and just gently forcing it apart. The idea is that the support material should just break away, and with all of these 3D printing slicing programs, the critical factors are how dense is your support material and how big is the gap between the support layer and the object. If you get it to the gap too big, the object droops down. You can see here there's just been a couple of strands that are drooping down, obviously unsupported. If you get it too small, then the object sticks very firmly to its support and it's very difficult to remove. So there's these big pieces here, and then various little pieces dotted around, which may have to come out, or possibly I'll leave, because the customer will know best which bits are the object and which bits are support that needs to be removed. Those towers were just to support the end of a tiny amount of support material that's in that hole. I would have said that was quite unnecessary, but the slicer obviously doesn't know which bits are vital and which bits aren't, and tends to put it everywhere. Now this support here I'm pretty sure is, again, one side of the support that's in this hole. So the support material will be going through the hole. Now when I break that away, it leaves a nice clean surface behind it. It's not the easiest to remove. But you can change the density setting of your support material to have more or less of it, and there we go. Obviously here I've got quite a lot. It may almost be worth going back to the original model and inspecting it to see where the holes are, and then I'll know which bits to remove and which bits to be careful of. So the support structures here look very strong, and I think probably could be made substantially weaker to make this easier to remove. But that's a setting that we can control. Sometimes just squeezing it is enough to break the bonds and force it to come away. That seemed to work quite well there. I think all of this is support. And really you just have to take your time, little movements, keep loosening it, applying force in the right places. Keeping your fingers out of the way, because even though the screwdriver's blunt, you can still jab it straight into your fingers if you're not careful. the object itself has a solid skin and a honeycomb infill, which makes it quite strong. The support layer is deliberately weak, so whenever you put stress on it, it should always shear at the boundary between the support and the main part, and not damage it. At least that's what I'm relying on. Let's just get the blade in there, separate that. These little bits of support are going through the hole. Actually, small holes like this print very well without support, so it really doesn't need it, but never mind. There we go. These little threads can probably come off. Cutting through this support, it's actually going to be easier than breaking it because it's supported on both sides. I can't pull it through. If I cut one side off, hopefully There we are, you can see the hole now. I should just be able to pull the other half through from the other side. Nearly there now. So it's that's certainly not the easiest support removal that I've had, but this is quite a complex part with a lot of support, and I obviously chose a very dense setting, and there we go, that's worked. Taking the sides off allows me to now just push through and clear those holes. I'll need to get a slightly finer tool to do the little holes, small screwdriver, but I think that's worked extremely well. Quite a complex, small detailed part, printed with support material turned on. I hope that's interesting. Thanks for watching.